So let's just see how we can delete a node from a particular position in the doubly linked list. So here we have the doubly linked list with the node 100, 200 and 300. So let's now see how we can delete any of the nodes. That means we can delete from the first position, we can delete the node from the last position, and also we can delete the node from any middle position. So here we have created the doubly linked list with the node 100, 200 and 300. Now here we're going to create the function to delete a node from a particular position. So the function will return one struct node type pointer, and we're going to call the function delete at position. Now the function will take one struct node type pointer head, and also we have to pass the position from where we wanted to delete the node. Now first of all we have to check if the list is empty. So the list is empty, that means there are no nodes in the list and the head pointer is pointing to null. So here we can check that if the head is pointing to null, that means the list is empty. So in that case we don't have to do anything, we can just simply print list is empty and we can just return null. Otherwise, if the list has nodes, so suppose the list has multiple nodes and we need to delete any node at a particular position. So in that case we need the temporary pointer which will initially point to the head, and then we have to use that temporary pointer and we have to traverse to that particular position to delete that particular node. So here we're going to create the temporary pointer struct node type pointer temporary, which will initially point to the head node. Now we have to traverse to the position where we wanted to delete the node. So we're going to use the loop. So the I will start from 1. Now in every iteration we have to check if the temp is null or not. And also we're going to check if the I is less than the position. So we're going to run this loop as long as the temporary pointer is not null and also the I is less than the position. Now inside the loop, in every iteration we're going to shift the temporary pointer to the next node. So this temporary pointer will initially point to this head, and then in every iteration we're going to shift this to the next node until we reach to that particular node. Now after the loop ends, here we have to check if the position is valid or not. So after the end of this loop, if we check that if the temporary pointer has become null or the position is less than 1, so that means if the temporary pointer is null or the position is negative or 0, in both the cases we're gonna print position is out of range, and then we're just gonna return head. So here we're basically checking after the end of this loop, if the temporary pointer is pointing to null, that means it is out of the range, and also we are checking if the position is less than 1. So if the position is negative or the temporary pointer is null, that means that is out of the range of our linked list. So in both of the cases we are going to print position out of range and we are going to return. Otherwise, if everything is alright, then we are going to perform the deletion. So first of all, if we check that the temporary pointer is the head, then we have to delete the first node. So after the traversal, the temporary pointer is pointing to head, that means we have to delete the first node. Now to delete the first node, we have to shift the head pointer to head next. So that means we are shifting this head pointer to the next node. And now we're gonna check if the head is not null. So after the shift, if the head is not null, that means the head is pointing to some other node. So in that case, we have to set null to the previous pointer of this new head node. So we're gonna set new head's previous pointer will be set to null, and then we have to free the memory allocated by this node, which is pointed by this temporary pointer. So free the temporary node, and then we can just return the new head after the deletion of the first node. So that means we have deleted this node and also freed the memory, and we have made this node as the new head node. So that is to delete the first node. So we have seen how to delete the head node. Now suppose after the traversal, the temporary pointer is pointing to some other node which we have to delete. So first of all, we have to check that the node to delete is not the last node. So here we can perform the check if the temporary pointer's next node is not equal null. So if the temporary pointer's next node is not null, that means this is not the last node. So if this is not the last node, then we have to update the previous pointer of this next node, and it should point to this previous node of the temporary pointer. So that means we have to set the temporary pointer's next node's previous pointer should point to the temporary pointer's previous node. So here we are basically setting this link. So the temporary pointer's next node means this node. So this node's previous pointer will point to this previous node. So the temprev means this node. So this previous pointer of this next node will point to the next node of this previous pointer. So we are basically bypassing this node so that this will be deleted from the list. So here we have to set temporary pointers next node's previous pointer should point to the temporary pointer's previous node. So this is in case that is not the last node. So now we're gonna check if the temporary node's previous pointer is not null. So if the temporary pointer's previous node is not null, that means we have to set the link from this node to this node. So we have to set temporary pointer's previous node's next pointer should point to the temporary pointer's next node. So that means we are setting this link. Temporary pointer's previous node means this node. So this node's next pointer, so this next pointer should point to this next node of this temporary pointer means this node. So we are basically setting this link. So here we're gonna set the link temporary pointer's previous node's next pointer should point to the next node of the temporary pointer. So that means we have successfully set those two links. So that means this node is now isolated from the entire linked list. So now we can free the memory of this node. So here we're gonna free the memory of the temporary node just to prevent the memory leak, and then we can return the new head pointer. So our function is ready. Now here currently you can see we have 3 nodes in the linked list. Now we can call the function delete at position. So first of all we have to pass the head pointer and then the position where we wanted to delete the node. So first of all let's just pass 1 to delete the first node. So after the deletion it will return the new head pointer, and we're just gonna print the list again. So you can see after the deletion of the first node we are left with 2 nodes and the first node is removed from the list. Similarly we can pass any position, we can pass 2. You can see the second node 200 is removed from the list. So this way we can pass any position and that particular node will be removed from the list. So this is the way we can delete any node from a particular position in the doubly linked list. So hope you understand the concept. See you in the next one. Take care.